This section is just like the last one. We're just putting some word problems to it. And honestly, there's a lot of exponential growth models in real life. Anything that keeps doubling or tripling, like they were saying earlier on with this virus that it was going, every person infects two people, in which case it means it's doubling. That's exponential growth. That's why it's so scary. Bank accounts, if your bank account keeps going up by 10%, or not 10%, it's not going to do that, but maybe you're earning like 1% interest each year. Every year you're multiplying by 1.01, so you're timesing it by the same number time and time and time again. So that's another example of an exponential model. So these type of things, it's nice to be able to use logarithms to solve, and that's what we're going to be doing in this section. So reading through this word problem, Carlos is taking an initial dose of prescription medication. The relationship between the elapsed time in hours since he took the first dose and the amount of medication m of t in milligrams in his bloodstream is modeled by the following function. So this negative in the exponent means that it's an exponential decrease, just so you guys know, which makes sense. You take the medication and it slowly leaves your system. So in how many hours will Carlos have 1 milligram of medication remaining in his bloodstream? Now think about this. This is asking how many hours, right? So it's asking for t, it's asking for the time, and it's telling us that there's 1 milligram of medication. So m is going to be 1. So that's what we're going to do. We're going to go ahead and substitute that 1 in for m. So we have that m of t is 20e to the negative 0.8t. So m of t is 1, and guess what? We got to solve for t. So how do we solve for t? Well, it's just like the last section. So we're going to divide by 20 to start it. So we have 1 divided by 20. Let's go ahead and divide that 20. So 1 divided by 20, let's go ahead and just put that in the calculator, see if it gives us a nice decimal to use instead, 0.05. Sounds good, let's use that. So we're going to have 0.05 equals e to the negative 0.8t. So what do we do next? We're going to go ahead and do the log, natural log in this case, because we want to get e, or since we have a base of e. And what we do to one side, we must do the other. Keep making mistakes here, give me a second. And so from there, the exponent comes down. And the natural log of e just ends up being 1. So we have negative 0.8t equals natural log of 0.05. And then we just got to divide the negative 0.8 to the other side. And negative natural log of 0.05 over 0.8 is our value for t. We just go ahead and put that inside of the calculator. So negative natural log of 0.05 divided by 0.8 is 3 point, and they're saying the nearest hundredth, so we'll go to the second decimal place. 3.74 is our value for t.